files. Normally, when you take any data item, if you declare a data item, the data items means if you declare variables, whatever may be the variable, they'll get space in memory. So in memory, there will be memory locations allotted for the variables. All the variables, the program, entire thing will be present in memory. But when you take the memory, it is volatile one. Volatile. Memory is volatile. That means it will lose the data, the values as soon as power goes off. So it is not a permanent storage device. Because only during the execution of the program, the variables will be there. And once the execution is over or system is switched off, then the data will be removed from memory. But sometimes, suppose if you want data to be available continuously for later uses, then we have to go for files, because files will be stored in secondary storage device. Files are stored in secondary storage device, which is nothing but hard disk, and it will be stored permanently there. So hard disk is a non-volatile memory, means it will be there permanently. So file will be present here in the disk. Even the programs, whatever you write, they will be there in the disk. And if you are executing a program, only that program is brought into the memory for execution. Otherwise, the programs, the data files, whatever you have, they will be permanently stored in hard disk or secondary storage device, because it's a non-volatile memory, and it is also very huge in size. So a file is nothing but the area in secondary storage device where the data is permanently stored. So that is the file. Now, if you want to access the file, means if you want to read or write the file, we use in C the file pointer. File pointer is the one which will be used to access the file, because when you take the pointer, the file pointer, it will be pointing to the buffer of the memory. What is that buffer? I'll give you. So when you take this file, it's a structure and it is pointer to structure. To access the files, we use file asterisk the file pointer name, so that we can access the file which is brought into the memory. Normally, when you take the files, the data files, the program files, whatever it is, they are stored in the disk. And suppose if it is a data file, you want to access it through C program, then first it is brought into the memory, then it is used. So otherwise the program cannot access the disk directly. It can access only the memory. So before before the program access the file must be brought into the memory. So when you take the file, there are some important operations with the file, like in Python. So there are file operations, and mainly there are several file operations, but mainly there are two operations. One is opening a file, and closing a file. So closing a file. So what happens when you open a file? So when you take, first we'll write the syntax of opening. So we'll see opening of the file. Opening the file. So to open the file, we use the function fopen. Fopen function is used to open the file, and the syntax of this is it will return pointer to file asterisk and fopen. Here the file details means name or path. File details you have to give as first parameter. Then you have to give the mode as second parameter. Both are strings. This is it gives the file name, and or path, full path of the file. Now, when you just give the file name, it will search in the local directory. If you take full path, it will access the file from wherever, whichever path you mention. Now, when you take this, this is the file to open. The mode gives, like in Python, the mode is same. When you take mode of the file, there are different modes like read mode, write mode, append mode, then read plus, R plus, W plus, A plus, then there is text mode, binary mode. These are the different modes, and this is actually always combined with one of this. So you can use one among this and one among this, and you, by default it is T mode, text mode, which is T. So this is default. So when you take the read mode here, this is read mode. File is open only for reading purpose. Only for reading purpose. Now W is write mode. Only for writing. Only for writing. You can use the file only for writing. Now append mode. Now before we go to the append mode, the read mode is read mode requires file to be present. So read mode, if you are opening a file in read mode, file must be present. File must be present. Otherwise, it is an error. Must be present. It has only the existing files can be opened in read mode, and when it is write mode, file need not be present. If it is write mode, file need not be present. File need not be present. Now, if present, the old contents will be erased. Old contents will be erased. So this is very dangerous. If you open a file by existing file by mistake in write mode, whatever old contents present, they will be erased. They will be removed. So if not present, it is created. It is created. This is write mode. So if file is present, it is actually a problem. A problem means old contents will be erased. So you have to be very careful. If you are opening the existing file in write mode and the file is important, the entire contents will be lost. So you have to be careful when you open a file in write mode. Append mode, if file is not present, it is going to be created. Now append mode is same as write mode, but there are two things. If the file is present, the old contents will be retained. If file is present, old contents will be retained. This is for writing. Again, for writing means adding to the existing contents. Adding to the existing contents. So it is same as the write mode, but the whatever contents you add, it will be appended to the file. So the old, even if the file is present, the old contents are going to be retained. That is append mode. If the file is not there, it is going to be created. If the file is not there, it is going to be created. Here R plus is same as read mode, but you can additionally do write. Read plus write. Same as write means file must be there. Whatever rules applicable to read mode, that will be applicable to R plus. So same as read mode plus you can do the write operation. This is same as write mode plus you can do the read operation. This is same as append mode plus you can do the read operation. So these are the different modes that are there in C to access the files. So one of them you have to use, only one option among this you have to use. And when you take the second set of options, the second set of options will have two options. One is T, another is B. T and B. So T is the default. T means here text mode. T means text mode. B means binary mode. Same thing is also applicable in Python. So text by this is the default. If I simply open a file in R, then it is a text file. When I say RB, it is a binary file. So if I simply say WT, if I say WT, it is text file. This is same as W. If I want a binary file to be written, I have to say WB. So this is how the files are opened. Now, when you take the text mode and binary mode, there are some differences. When you take the text and binary, there are differences with respect to several things. I'll give you text and binary. Now, in case of writing the data, if it is simple, you can text mode. It is not necessary that only text should be stored. You can store numbers. Binary mode, you can store any data. So normal text, when you take normal text, means other than numbers. Here I mean normal text here. Normal text means this is other than data. All will be stored in same way. So in text file, it is stored in same way. There is no difference. Even in so the normal text is stored in ASCII form. Here also it is ASCII form. Now, if you take numbers, numbers are stored in ASCII form in text file, and here it is stored in 2's complement form. So that is the advantage here. Suppose if I want to store 1, 2, 3, 4, 5, 6, 7, suppose 8, if I take this. Now, if I store it in text file, this is every one is stored as a byte. So 8 bytes will be required. Suppose if the same thing, if I use in 2's complement, it requires only 4 bytes because it will be stored as integer. So it requires only 4 bytes. So when it is numbers, there is a difference here. This is numbers in file, text file, they will be stored in ASCII form. Same thing in binary form means binary mode means they are stored in 2's complement form. So they will be stored in an efficient way. But the problem is always conversion should happen. So when you are using the program, they'll be okay. There should be conversion happening between ASCII to binary, the 2's complement to ASCII. So that is about the numbers that are stored in text and binary form. The next difference is this is actually normal text is same. The next difference is new line. So new line is stored as combination of carriage return and form feed. In case of text file, here it is stored as only one character. So that is one more advantage. Then one more thing is end of file. So there is end of file is stored here. End of file is stored with some ASCII value. EOF, it is ASCII value is stored, and here no end of file symbol. No end of file symbol. So these are the differences between text mode and binary mode, but normally, mostly it is text mode. If it is binary mode, if you want to store the numbers in an efficient way, then we can go for binary mode. Otherwise, the data is by default stored in text mode. So generally, we go for text mode until unless there is a specific reason, we don't go for binary mode. So that is the mode. So by default, it is text mode. And if you want, you can go for binary mode. The differences between text and binary have given. So this is how the fopen works. Now, if I come back to fopen here. So here you have to mention the mode and file name. once you mention, for example, I'll take example. So if I take here, suppose file, because to declare a pointer FP file, you require a file pointer. So I'll say fopen something like 1.txt, and I want to read it. So this is how the open is given. Once I say fopen. So what happens here is once I say fopen, so what happens here is there will be disk. There will be disk where the file is stored. We'll assume that the file is present. Actually, it searches for this 1.txt in the current folder. Current folder is the folder where the program is running. So we'll assume that that file is present. 1.txt is present in the current folder. Now this is the secondary storage. Now I'll then the program will be there. Program is kept here. Whatever code we are writing, it will be there. Now, whenever I write this statement within the memory, of course, program will also be in memory, but it is shown separately there. Within the memory, a buffer is created. Buffer is the temporary area in memory, which will be holding the data of the file temporarily during the execution of the program. So a buffer is created. So when I say fopen, buffer in memory is created, and the size of the data equals to the buffer size will be read and kept in the buffer at a time. So buffer is read and kept. And after buffer is allotted, the file part of the file which is equivalent to the size of the buffer is read and kept, and the starting address. So there will be FPTR within the program. The starting address, actually FPTR will also have some space in memory. The starting address, suppose assume that this is 6000. Starting address of this buffer will be moved into FPTR. So this is how it happens. Now, suppose by chance if fopen fails, because suppose if it is read mode and file is not there, then it will return null. If fopen fails, it returns null. So if FPTR is null means fopen has failed. If FPTR has some value, that means fopen is successful. So this is what that happens when you open a file. Suppose if it is write mode, then suppose if you are opening a file in write mode, suppose 2.txt, you are creating 2.txt in write mode. So what happens here is a buffer for the file is created, because it is buffer is created, and the starting address will be stored there. Suppose if it is 8000, 8000 will be stored. So when you start writing, we'll see how to write. It will be written into the buffer. So only when buffer is full, the data is written into the file. File is created here in the disk. So when buffer is full, it is written into the disk. So when you are reading or writing, you will be reading or writing the buffer, not the file directly. So file cannot be read directly or written directly. You will be reading or writing the buffer associated with the file, not the file itself. So when you open the file in read mode, the contents of the file that are there in the disk will be brought at a time, will be brought into the buffer. The size of the contents read will be equals to the size of the buffer. Then from there, the file keep on read. Similarly, when you write it, you will be writing in different forms, like one character, one field, one record. At a time, you may write array of contents. Whatever you write, you will be writing into the buffer. Only when buffer is full, it will be written into the disk. Now that is about fopen. Now when you take fclose, this is opening the file. Fclose is also associated with something, this buffer. So I want to complete it here. So closing the file, if you take, see all these concepts I think I have given in Python, but anyhow I'm repeating. So there is fclose file pointer. So normally the data in the buffer, suppose if you have opened for write mode, the data in the buffer is returned to the disk only when buffer is full. But when you close the file, suppose if buffer is partially full, when they close the file, whatever pending data to be written that is available in the buffer is returned to the disk. So what happens when you close the file? The pending data to be written which is available in the buffer is returned to the disk or file area. That is one thing. Then the second thing, what happens when you say fclose is the buffer is released. So in fopen, buffer is allotted to the file. In fclose, buffer is released. But in case of fopen, after buffer is allotted, the contents of the file will be read and kept into the buffer. Kept into the buffer. Then so first buffer is allotted when you open a file in read mode. Buffer is allotted, the contents of the file will be read and kept in the buffer. When you close, first contents, pending content. Suppose if you have opened for read mode, nothing pending to write. Suppose if you have opened in write mode or append mode, there may be some data pending to be written. So when you say fclose, the pending data to be returned to the disk, pending data returned to the file will be first written. So fclose first writes the pending data that is there in the buffer to the disk, then the buffer is released. So these are the important steps. So when you open a file, the first important step is buffer is allotted. So opening the file means allotting the buffer to the file so that the data transfer happens through the buffer, because the program cannot write the data directly to the disk. The operating system will do for the program, but the program will be writing and reading. There are several reasons, like speed is one reason, because you will be writing the data, reading the data character by character, field by field. It is not possible to read the data from the disk character by character or field by field. It will be read or written page by page. So that's so because then only the time will be saved. Otherwise reading, because disk will have read write head and moving read write head, the shaft, rotating shaft will be time consuming operation. Each time if you read one character or write one character, it is time consuming. So normally what happens is it will be burst mode reading, bulk reading happens. Even though you are reading one character, the entire file, you are reading one character, the full contents equals to the size of the buffer will be read at a time and kept in the buffer, so that the efficiency of reading the disk is maintained. Otherwise the reading becomes inefficient. Similarly, when you write, it is burst mode writing, entire buffer is written at a time, so that you can reduce the movement of read write heads, and rotation of the shaft will be reduced if you do it in bulk. So the reading and writing will be efficient. So that is the reason why buffer is involved in reading and writing uh, of the file. Not it is not direct reading and writing. So this is how that is the reason why fopen and fclose are important operations. So if you forget uh, fclose statement, there is a possibility that you will be losing the data, because normally the buffer data is returned to the disk only when buffer is full. Now when you complete the program, there is a possibility that buffer is partially full. Most of the times it will be partially full, and if you terminate the program without closing, then the data is going to be you are going to lose the data. You are going to lose the data. So that is the fopen and close statements. Now there are several other statements present related with files, activities or operations present. So we have seen like operations related with the file. So if you want to
Sir, you are muted, sir.
Yes, scanf fscanf function is used to read the data. So we are seeing about operations related with files. So we'll see first fscanf, the fprintf before we see the other operations. So fscanf is same as scanf. Fscanf is same as scanf. Only it is like in case of scanf, we have formatted string here, format specification here, then the list of variables. This is how we use scanf. Now the same thing will also be there in fscanf. Formatted, it will be there, formatted string and list of variables, and before that there will be file pointer. Remaining things are same. So this is how we read fscanf. So scanf is just the same as scanf, but scanf reads the data from the keyboard. Fscanf reads the data from the open file. So by the time you say fscanf, you must have opened the file. So whatever pointer that is available with the file, like here, this remaining operations you will be doing based on this pointer. So after you open, you will have a pointer. Once you obtain the pointer, the operations, whatever you do on files, is related with the pointer. So if I use fscanf, I can say fptr. I can read the data. Read the data in the read the data in required form from the file, but only thing is the file must have been opened by that time, and the pointer of the file must be passed there. So this is fscanf. It is just similar to scanf. Even you can replace scanf. I need not use scanf. I can use fscanf to read the data from the keyboard. Normally we use scanf to read the data from the keyboard. Fscanf is used to read the data from file. You can use fscanf to read the data from the keyboard by saying, in place of file pointer, if you say std in, then fscanf std in, remaining thing, if you keep it, it is just the same as scanf. So that is that is actually the fscanf function. So even the job of the scanf, you can do it with the help of fscanf. So that is actually the formatted reading. Now, if you want to write the data in formatted way, write the data in formatted way, you can use fprintf. Like fscanf, there is fprintf, and it is fprintf is same as printf, like formatted string, list of variables, but here there will be file pointer. So file pointer is used to read. File pointer is used to access the data, because we'll be accessing the data. We'll be accessing the data from the buffer, not directly from the file. So the file pointer plays the key role there. So file pointer, then format of the string, then format of the string, then what we give, list of variables. So you can write, it will work same as printf. Only thing is, additionally there will be file pointer, similar to fscanf replacing scanf. Fprintf can also replace scanf. If printf also can replace the scanf. By saying here, in place of file pointer, if I give std out. So std in is standard input device. Keyboard is considered as standard input device. Std out is standard output device. Std out is standard output device, which is nothing but the monitor. So you can read and write the data from the file using fscanf and fprintf. Fscanf and fprintf, and even scanf and printf can be replaced with fscanf and fprintf by writing standard stdin as a pointer, which is referring to the keyboard, and stdout as pointer, which is referring to referring the monitor. So that is how we use it. Use the fscanf and fprintf. Next, so these are the two functions we use generally. Then you can also use one more function. This is actually to read the data formatted reading. So I want to read one integer, one string, or one real number. So it is formatted reading. So formatted reading or writing is done with the help of fscanf and fprintf. Next, we'll see a function called getC. So next we'll see fgetC function. So we'll use fgetC, then we'll write the program. So fgetC. So there is a fgetC function. It is also to read the data from the keyboard, but read the data from the file. It will read one character at a time. Read one character at a time from the file. From the file. So character by character reading, like we have seen getchar, getch, getche. They read one character from the keyboard. Fgetc reads one character from the keyboard, and it will keep on read the data from the keyboard until end of the file is reached. End of the file is nothing but -1. Or you can say EOF or end of the file or FEOF. So you can use any one of this to check whether end of the file is reached or not. So fgetc, if you take the syntax, what fgetc does is, so fgetc, it returns a character, and you have to give the file pointer. You have to give file pointer. So this is how we read the character by character from the file. And once we read the character by character from the file, and if end of the file is reached, means all the contents of the file are read, all the contents of the file are read, then end of the file is reached, and this will return EOF. It will return EOF when end of the file is reached. Otherwise it returns the character. So end of the file EOF is nothing but -1. We'll write the program, then we'll see. So I'll take one program, hash include stdio.h. So I'll say file read. So .c. So where this is, I'll create one text file there. So task courseworks 2020. Okay. So here I'll open the file main fptr equals to fopen. Now I'll take sample.txt. It should be there in the current folder. So I'll open it in read mode. So I'll say character ch. I'll declare here character ch. While ch equals to fgetc fptr, and it should be not equals to -1. Be not equals to -1. So not equals to EOF. So I'll print the character. Print. I'll take the same file. Print F, or we'll say put C, put char ch. So this is what I'll do is I'll open the same program and I'll print. I'll open the same program and print. So I'll say file read.c. Same program is opened and printed. Then finally I'll close the file. So I'll say f close fptr. I'll execute this. So what it is saying, main. So it is printing the same file. Whatever I have written, it is printed. You can observe the same file data is printed. So it is reading one character at a time. And I can also write here -1 because EOF